Hello everyone. So now we'll start with the next topic. So that is band reject filters. So in band reject filters, again there are two types. One is wide band reject filter. The second is narrow band reject filter. So first we'll start with the wide band reject filter here. So in this filter we are going to use a low pass filter, a high pass filter and a summing amplifier. So first thing, there is one condition here. So to realize the band reject response, the low cutoff frequency of FL of the high pass filter must be larger than the high cutoff frequency FH of the low pass filter. Is nothing but, now here the value of FH need to be smaller, the value of FL need to be larger. Okay, where FL is used for high frequency, that is high pass filter, and FH is used for low pass filter, and the condition is that like this. Here the value of FH of a low pass filter need to be smaller, and the value of FL of high pass filter need to be larger. Okay, so that's one scenario which is different from other filters. So now how this circuit works now. So now here this is a high pass filter, this is a low pass filter, this is a summing amplifiers. This R1 and RF is used to provide the gain of this high pass, this R1 and RF dash is used to provide the gain of this low pass, and this is used to provide the summing amplifier, because two resistors R2 and R3 are connected to the inverting terminal of op amp, which acts as a inverting summing amplifier. So now we will study the working of the circuit. Okay, so now first thing, where Vin is the input signal which is connected between the non-inverting terminal of high pass and low pass. Okay, and we know that when the frequency of an input signal is low, the reactance of capacitors is very high. Okay, so now assuming that now the frequency of this input signal is low, nothing but the reactance of this capacitor is very high, and this capacitor acts as an open circuit. Therefore, there is no path here to flow the input signal with respect to frequency to the output side. So similarly, if I come to this, here this capacitor reactance is also very high, hence it acts as an open circuit, but it has a path to flow towards the output side. So we can say that this is a low pass filter which allows the frequency components of input signal towards the output side until it reaches its cutoff frequency, which is FH. So the same thing shown here. So this is the output of low pass filter. So it will provide the constant gain at the output side until the frequency of input signal reaches the cutoff frequency FH. As soon as the cutoff frequency reached, here the gain of this low pass filter will start reducing at a 20 dB per decade and reaches to 0. This is because the reactance of this capacitor starts reducing and it acts as a short circuit. At this node, the input voltage becomes 0. Okay, so now similarly, when the frequency of this input signal again starts increases and reaches the value of FL. Okay, once it reaches the value of FL, so this is the cutoff frequency for high pass filter. So at that time, the reactance of this capacitor acts as a short circuit and allows the frequency components to pass through the circuit and available at the output side. Okay, so now these are the remaining frequency components of the input which passes through this circuit. So here to assemble the output of these two at the output side, we are using a summing amplifier. So initially the summing amplifier uses R3 resistance to pass the output, and afterwards it uses R2 for the high pass filter to pass the output towards the output of this inverting summing amplifier. So this is about band pass, that is wide band reject filter. Okay, and this is a graph where it allows the low frequency and the high frequency components and rejecting the frequency components which is between FH and FL, okay, where FH must be lesser than FL. That is the condition here. So this is about wideband reject filter. So if you have any doubts, you can text me a message. Thank you.